So this lesson is going to be covering the chain rule of derivatives, and the main question here we're going to be answering is that how do we take a derivative of a composite function? A composite function is basically a function within a function. So I'll write that right here, the chain rule. This is a very important rule, and it's going to be used a lot when we're finding derivatives of functions, because you're not just going to get a simple derivative, a simple function with a simple derivative. Sometimes you're going to have a function within a function, and you have to try to find a derivative of that. So the main question we're going to be answering is, how do we take a derivative of a composite function? Composite meaning within. So it's going to be a function within a function. So the general formula for the chain rule is written as this. So there's going to be two functions, f and g. I'm going to use f and g. So the derivative of f of g of x. So the way we say this is that we say derivative of f of g of x. That's how we say when we're actually saying what this is, what this derivative is. It's basically the derivative of the outside. So that means that the outside function here is f. The outside is f. Times the derivative of the inside function. And the inside function here we consider g. So this right here is a derivative. This right here is the derivative of the outside function times the derivative of the inside function, which is g of x. So a quick example of this this rule, the chain rule, is this. So let's say we have function f of x is equal to 1 over 4x minus 1 cubed, right? Now you see that we have a function within a function right here. You see that we have 4x minus 1 inside of parentheses, and it's cubed. Say, like, we can compare this to 1 over x cubed. When we had 1 over x cubed, it's a little similar to this, but the big difference here is that there's a entirely new function in the place of x. So that's where the chain rule applies. That's when the chain rule comes in, and we start to apply the properties of the chain rule. So first the first step is to identify f of x, the outside function, and the inside function. The outside function here we already determined to be 1 over x cubed, but we're not gonna so it's 1 over x cubed, but we're not gonna just use 1 over x cubed as the outside function. We know that in 4x minus 1 is in the place of x, in the place of x, where when we had 1 over x cubed. So what we're gonna do is use a little property called u substitution for derivatives, and it's just a simple property. We basically make u like any variable, but it's usually going to be the variable u. We can make u equals 4x minus 1 and change this function when we're trying to calculate the derivative of the outside function. We can change this function into 1 over u cubed. It's basically the same thing as 1 over x cubed, but we're using u just to make it a little bit more sophisticated and just keep everything organized. So the derivative of 1 over u cubed is just simply, so what we're gonna have to do here is make this a -3 and then use the power rule, because u to the -3 is the same thing as this. So we bring the 3 to the front, right? Then we have u, and we know u is equal to 4x minus 1. And then we subtract 1 from here, right? So -3 minus -1 is just -4. And the value we get here now is -3 over u to the 4. So that's the derivative of the outside function. And we already know that u is equal to 4x minus 1. We can substitute back 4x minus 1. 4x minus 1 to the 4th. So that's the derivative of the outside function. So now we know that the outside function, the derivative of the outside function, so let me take this out. So now we know that the derivative of the outside function, right here. So I'm going to label it derivative of outside function. Now we need to know the derivative of the inside function, and the inside function is 4x minus 1. So 4x minus 1 is the inside function because it's inside of the parentheses. So what we're going to do now is make another little arrow. Derivative of 4x minus 1. Derivative of 4x minus 1. So derivative of 4x is just 4. Derivative of -1 is just 0. So the overall derivative of the inside is just 4. So I'm going to label this as derivative of inside. So now that we have the derivative of the outside and the derivative of the inside, now we can apply the property of the chain rule and find our full derivative. So now we're going to write 1 over, no, we had derivative of the outside is -3 over 4x minus 1 to the 4th. And we multiply this by, what is the chain rule saying? It's saying that we need to take the derivative of the outside function times the derivative of the inside function. And the derivative of the inside function we determined to be was 4. So we had to multiply this entire derivative of the outside by 4. And this is just simple multiplication. We put this over 1, -3. -3 times 4 is just -12. So the final derivative, so f prime of x right here. Let me just write f prime of x, just so you know we are calculating the derivative now. So -3 times -4 is just -12 over, and the denominator just stays the same because this denominator times 1 is just itself. So 4x minus 1 to the 4th. And our final answer is -12 over 4x minus 1 to the 4th. So we can do another problem too. Let's do another problem. So question 2. Let's do f of x. Let's do a little bit of a problem that makes us think. So let's do a square root problem. So 3x squared minus 7x plus 1. So in this kind of problem, we're gonna need to try to rearrange this question, this formula, so that we have an outside function and an inside function. Like, it's obvious we have an outside function and an inside function. We're gonna make that obvious. So what we're gonna do here is rearrange this into parentheses. So we know that the square root is just the function raised to the 1/2 power. So we can do that here. So 3x squared minus 7x plus 1 to the 1/2 power. This is the same thing as this. Same thing. But this second way, it makes it easier for us to find an outside function and an inside function. So now we can determine what the outside function is. So the outside function is just x to the 1/2. Once again, we use that the u sub method we used previously. So when we take the derivative of, so in this case, u is equal to 3x squared minus 7x plus 1, right? Now we just substitute that in for u. So u, wait, no. So it's going to be u to the 1/2. And we take the derivative of that now. This is a simple power rule. You bring down the 1/2. Then we subtract 1 from the 1/2. So 1/2 minus 1 is just negative 1/2. And we simplify this to 1 over 2 radical u. This is what we get. And then we can substitute back in the u. And our u, well, we substituted 3x squared minus 7x plus 1 for u. So that's the derivative of the outside function. So let me label that. The derivative of the outside function. Now, going back here now that we have the derivative of the outside function, we need to find the derivative of the inside function. And then since we rearrange this problem so that it's obvious that we have an inside function and an outside function, now we can take the derivative of the inside function, which is this 3x squared minus 7x plus 1. So the derivative of 3x squared minus 7x plus 1 is just, so 3x squared, derivative of 3x squared is 6x. Derivative of negative 7x is just negative 7. Derivative of positive 1 is just 0 because it's a constant. And that's the derivative of the inside function. So we'll label that as well. I'm just labeling it so because just to make it obvious, but when you're doing it in an exam or quiz, you're gonna have to do this process very fast. So it's it'll be so it's beneficial if you try to not try to memorize, but try to practice this chain rule. So you know how to do it fast and during time constraints. So this is going to be the derivative of the inside function. So now that we've determined that the derivative of the outside function and the inside function, now all we have to do is just put everything together. So let's put everything together. So f prime of x. So the first thing we're going to put down is the derivative of the outside function, and that is 1 over 2 radical 3x squared minus 7x plus 1. And this is going to be multiplied by the derivative of the inside function, which is 6x minus 7. And our final derivative is basically, you can put this over the 6x minus 7 over the entire denominator. (3x squared minus 7x plus 1). And our final derivative is this 6x minus 7 over 2 radical 3x squared minus 7x plus 1.